Hi, Matthias. Welcome back. And what I recognize, or what I noticed, is that I have a couple of your books on my shelf. So I was curious, and then I double checked that I have a couple of SOA books. I remember one is orange, so I forgot to pick it up. But yeah, so actually I read several of your books without knowing about you.
Oh, really? That's good to hear. Yeah. Yeah.
The last time we had a conversation regarding Cumulus and the microservices, and what's always interesting, the modularization or not. And this was one of my topics, and I think also yours. There are, there are a couple of ideas how you can modularize your application. And but before we start with the modularization, I always ask myself why we should even do it. So I can actually, I have to admit, I always tried, to prevent the modularization, because most of the project, it was just used because they could modularize and not because there was some benefit. So what's your opinion about modularization, or what's so let's say you would create your own pet projects, whatever you like, for your hobbies. Is modularization something you're thinking first, or what's your thinking process here?
Well, to be honest, I'm a great supporter of modularization. I believe that, software should be designed out of reusable building blocks.
Mm-hmm.
Now, certainly it depends on the complexity. If we are building a relatively simple software, then modularization is not so important. However, if we are doing large projects, it becomes more and more important.
Mm-hmm.
Even more so if we look at the enterprise architecture. For example, if we have a larger company, and then we look at the software architecture of their information system, then modularization becomes quite an issue. Let me give you an example. We are currently working with one of the larger retailer companies. And the problem that we are currently solving is particularly related to modularization, because this retailer has several channels, such as physical stores. Then they have B2C website and web store. They have a B2B web store and so on. And there are certain parts of the system which have until now they have not been designed as reusable building blocks. For example, pricing. They have a really complex algorithms how the price is calculated, and they have a lot of promotions and everything else. And unless this is a central building block which is reused, so a modular building block which is reused by all the different channels, if this is not implemented in such a way, then it really gets messy. Then you have to either pre-calculate prices in advance and copy them to different applications, or you have to to have these algorithms for calculating prices implemented on several places and so on. But this is just a simple example.
No, but it's a very good example. So I was in a very similar project. It turned out this was insurance. And it turned out that the insurance policy was calculated several times, depending on department. But for me, it is not modularization. It's more like, some, let's say, a business guru, someone who isn't even a programmer, but really knows how the business operates. He says now, our insurance policy has to be calculated once, period. And if one mathematician changes his mind, then it should be available immediately to all apps. And in your particular case, there should be some, I don't know how to call it, product owner, not even product owner, someone who knows retail very well and says, okay, if you would like to be the best retailer, our strength has to be flexible pricing. And the pricing has to be calculated only once, done. And all applications, all modules have to use this pricing.
Yeah, right.
This is like if you were, let's say, in a government, there would be one module which cares about the laws, Period. You cannot just invent your own laws. It's mine. If you would copy the pricing module, it is a bug. It is not even modularization. It's like, the business idea is not implemented one-to-one. It was some, developers tried or copy and pasted the code, which is a mistake.
Yeah, I agree.
So what I would see in your case, I would create a pricing monolith, which cares about pricing, and the other monoliths are calling the pricing monolith because they have to reuse the pricing, functionality.
Okay.
This is because if we switch it back, what I see in projects, I have to deal with consultants, developers. Now a little bit less because you waste time somewhere else, creating YAML or whatever. But let's say there was before the YAML time, right? So then developers were bored, maybe, and they tried to introduce modules without any business backing, logging module, configuration module, and whatever module. And I said, okay, if we are in retail business, why we care about logging? Yeah, we are retailers.
Okay.
If we're on Amazon, I would expect a shopping cart module. I would expect, pricing module or delivery module. But if someone tries, starts to create their own data layer module, something is wrong with the project because they spend more time thinking about the technology and less time about the business, right?
Well, this is where I certainly agree with you. Yeah, modularization has to be done in a well thought way, and you don't have to overdo it. But still, I think it's something you should follow in most projects. Well, how to design the modules, what is the granularity of modules, and how to separate the so-called business modules, or how should I say, modules which are directly related to the business domain of the software. How to separate this cross-cutting logic. This is certainly something which is quite important. And I also don't like to have such cross-cutting logic, such as, database handling module or logging module or something like that in any projects. Because I think today we have libraries and frameworks that take care of this.
Yeah, exactly.
Yeah.
Exactly. Yeah. If I have a cumulus, I don't care about transactions because transactions just happen. So this is what I meant. So cross-cutting concerns are... there's no more AOP, I would say, because it's a part of the platform. And no one, I would say, creates Java SE apps anymore from scratch. So sometimes, CLI is okay, but I mean, if you have a service, it's always easier to use something existing. And business modules, you said, is interesting because I call it business components. And for me, it is like a Java package with a business name. So what I do in my projects, I only allow top-level Java packages with business names. And these are my modules. And maybe, so this is also a monolith because if we start programming all the business packages or business modules or however we call it, all the modules are inside a jar or war. So from outside, you would say, this is a monolith, but for a good reason. We save a lot of time at the beginning, and we always can decide then after refactoring. And refactoring, by the way, means just copy the code over and hope it compiles. So we don't even try to have interfaces or whatever. It's just simple code. If the code is simple, refactoring is easy. This is my approach, right? So not OSGI or whatever, and hoping it will work. It would never work actually. And then we will create let's call it microservice or however. So a standalone process with a couple of business modules. So this works surprisingly well. And I always had to fight, with modularizers in my project. Always wanted to use an OSGI or whatever framework, and the complexity never paid off so far. I saw that.
Yeah, here is where I agree with you. Actually, how we are approaching this is you have this logical modularity and then physical or deployment modularity. So what I think it's very important that even smaller projects have this internal logical modularity. Even if you pack them into a single executable jar or whatever packing methodology you are using, but still that you separate the responsibilities of each module, whether this is a component, service, class, package, and so on, and that you define the interfaces between them. This can be then local Java interfaces, no problem. You can always refactor them to REST or other protocols and make them work in a physical or deployment modular topology where you pack each module into a microservice. But should you do it from the start? Depends. It depends from the size of the project, and particularly, well, to be completely honest, at least we don't have so many projects where we would foster modularity just because of technical reasons such as scalability and so on.
Exactly.
in the microservice development. However, in at least in projects where I work, having physical modularity through microservices often paid off with parallel work.
Yes.
So that different groups or teams could work in parallel on different functionalities. And once they have the ability to build and deploy the code as separate microservices, so almost no dependencies with other teams, it definitely accelerates and makes the development faster.
Okay, you are absolutely right. And this was actually my question I wanted to ask you right now. Are there any large projects out there? Because for me, there are only small projects, and every small project ships a physical, how you call it, physical module. So, we have in large enterprises, a large project would be actually a project which comprises several teams which are smaller, and in the best possible case, they don't even know each other, right? So this would be the best case. And they are shipping microservices. But if you look at the microservice from the outside, from above, it would be lots of duplication. There will be no alignment regarding there's separate apps, like a chaos actually. And the difference I would say right now is because small projects can create a single something. The single something can be simpler. And a few years ago, the enterprise architects tried, to oversee all the projects and try to create a reference architecture for everyone, which didn't work. So I would say what happened right now is the modules inside, or the smaller monolith is still monolith, because a small team, let's say 3, 4, or 5 people, are shipping a simple monolith, which can be actually quite complex. So I'm really thinking I would say for what was 5 years, 60-person projects. Now there are 5 to 10 developers, never more. And the rule is more 3 in my world, like 3 developers to 5, even in the large enterprise companies. And if there's a project with 60 developers, I was thinking, okay, maybe it's something not right there, right? So it's because I cannot just imagine 60 developers working on a thing. So I would do first is to create 12 teams, which ship 12 microservices, 12 monoliths. So I would say the wording is interesting because I think the modularization is completely dead in a team. So what you have a monolith with business packages. So the internal structure should be beautiful, well structured, simple. You recognized according to Java names what's inside, and but there is no factories, abstract factories. All the idea that a class should be replaceable is no more needed. So if we have several deployments a day, I can replace the class 5 times a day without reconfiguring a factory. So this is no more necessary, I would say. So because everything becomes simpler, there is no, I would say, almost all the Gang of 4 patterns, right, became part of the platform. So like a factory of dependency injection, right? Decorator, we have transactions. So whatever you looked at, the book is already part of the platform. It's a matter either of convention or just a single annotation. And even, the stability patterns like secret breaker, whatever, resilience patterns are also part of the platform. So there's actually nothing else to do from the technological perspective. And then the challenge is to just, to think in business terms, right?
But this is good, actually. I believe this is good. For example, at least in Cumulus EE framework, what we are trying to do is to provide all the necessary framework parts, so all the patterns and all the tools and utilities which developer needs. Yeah. Still, what I would suggest is that code is designed and then implemented in such a way that different parts are structured in such a way that they can potentially also be deployed separately. Yeah?
Yes.
And of course, today we are talking about microservices as a way how you can deploy them separately, but not necessarily. If you're using app servers, this can still be VARs or ERs, but it depends whether it's one or two or three or several in an application. But what we learned so far is that deploying things separately, for example, as a separate microservice, makes sense if the building block that you are developing is used by some other part or team or so on. In this case, in most cases makes sense to build it as a separate deployment unit. So, for example, as a microservice, probably in a few years we will talk about functions, but nevertheless, because then those clients which are using this functionality, they don't depend on the whole application of yours. They depend on a separate module. And for example, if they have a development environment, they can simply take the Docker image where only this component or this microservice is there, and they can set it up, and they don't mess with all the other complexity which is there in your application, but they don't need it.
Yeah.
And these are the scenarios where we foster microservices and actually this concept of separating the modules and packing them separately, not building the deployment monoliths. Yeah,
I'm absolutely with you. So for me, a module is a Dockerfile, and 10 years ago would be a war. So I started to do 2005, 2006, a war was a module. And then microservice meant to me one war is deployed on one single server. And then, of course, I did it for 5 years. And one point of time, you noticed that. And I noticed a little bit later that actually if you always, have to ship one war on one application server, you can skip the deployment phase, because why you need dynamic deployment if there's only one-to-one relation? But what it means, if the module is a war, let's say, or a jar, we don't need to use interfaces for segregation internally, because what I still see, you have two modules and there's one interface and one, well, let's say not module, one package, Java package, and one class injects the other class. And some still, from time to time, developers try to introduce an interface. And the problem, if you introduce an interface, you cannot name the implementation properly. So they call it impl. And it's okay, if you call it impl, it's over, right? But how you would call the next thing, impl 2, or what's your strategy there, right? So I would say, because the modules are coarser, I would say. So the modules now are small apps. So inside the module, you can write simple code without any, layer translation. Nothing is actually required, because no one cares about that. No one cares anymore whether, our exception is separated or no, or whether we are separating, technical from application exceptions, because at the end of the day, status code and HTTP codes are what matters, and not to know the exceptions. So because of the REST and ASCII and the war, we got actually the ultimate module, right? We can swap the entire runtime. I could swap, Quarkus with Cumulus, and I don't care. So, and Quarkus could be JDK 1.8 and Cumulus JDK 16 with complete different architecture, as long as the ASCII is the same. I don't care.
Which is good.
Very good. Which
is actually very good.
Yeah. I try to torture you a little bit, because you are, the modularizer, and I try to explain this in my project. But what you mentioned is like physical modularization and logical modularization, right?
Yeah, I said it like that. I don't know if these are really the exact words, but
But this is perfect for me, because the new words, which I really like, which means for me the logical modularization, which means nicely named Java packages, is very important. And I have, let's say, per physical module, 5 to 10 of them. But I try to avoid the number of physical modules, which are wars or jars. And what I think what will happen is, my opinion is this year it really happened, that more and more companies really noticed how expensive clouds actually are. So whatever you are doing, it costs, Would you like to have Elastic IP address? It costs you money. Would you like to have a NAT gateway? It costs you money, real money. I mean, it can go fast out of control. So, and what I see, if you would just, deploy a lots of microservices, you will spend 10 times as much money, because every microservice, regardless how small it is, it's not only, the running costs. the complexity is brutal. Really brutal. If you try, to create your own VPC, you did it properly for Azure or for AWS or for whoever cloud. Before you even ship your microservice, you will spend probably 1 day, fiddling with VPCs, nuts, and subnets and CIDRs and stuff like that. This is what we didn't have before because everything was already set up. So we just we could put the microservices to production. But now we need something like a module is not only a Dockerfile. A module would be a Dockerfile plus probably availability zone where it belongs, right? And even the old firewalls and NAT rules you also have to specify in the clouds. Otherwise, these services are not able to communicate with each other. So, and because the complexity is higher and higher, what I would suspect next year, back to monolith a little bit. So we push more stuff, more logical module to one physical module to make it the pricing a little bit more reasonable.
Well, this really depends, I believe, to where you deploy. For example, what we are working now is we mostly deploy to Kubernetes environment, and here,
on-premise.
On-premise or cloud. And what I really like with Kubernetes is that, it really makes no difference if you have a cloud-hosted Kubernetes on Google or on Amazon or Azure, or if you have an on-premise deployment. What you really need to do, you have those Docker files with microservices, and then you have the Kubernetes deployment descriptors. And where you configure how the deployment, how the communication, everything else goes on. And this works wherever the location of the Kubernetes cluster is.
This is the smallest problem. This is the smallest problem.
I agree with you that if a company has a cloud-based, Kubernetes cluster, they need to configure it, but they need to do it once actually, and then they can deploy different applications there. Yeah. But what I wanted to say is that once you move to Kubernetes, then maybe it makes sense to make microservice a little less coarse-grained, so have more microservices. So to make it simple, if I would deploy to classical virtual machines, I'm not talking about app servers anymore, because in our Cumulus EE framework, it's been now more than 6 years when we decided to have a framework where we don't need the app server anymore. We simply embed the runtime environment into
Let's say microprofile runtime. It's very good.
Right. Because this really makes sense. Yeah. And once you do this step, you make a huge step towards short runtime, flexibility, and so on. But don't let me get back to Kubernetes. Yeah. And once you start using Kubernetes, and all those functionalities it provides, so for example, health checking, automatic restarts, a pod autoscaler, and so on, then it starts to make sense to have a little more microservices than if you deploy to simple virtual machines. And Holy Grail here would actually be to have a code where you can specify, for example, whether you separate 3 or 4 business functionalities and build a system where you have 3 or 4 different microservices, or you pack everything together into a more monolithic deployment. If you know what I'm trying to say. Basically that the code would be structured and written in such a way that you can have several physical deployment units, so you can build and package it as several microservices. Or if you have a runtime environment where you don't need that, you can put this together into a monolith. This would be an ideal opportunity, but in practice, you have to deal a lot with configuration, deployment descriptors, POM, XML, or whatever build tool you're using.
This is not a problem. Even Cumulus are with me. So the app servers, I would even argue if you use something like Payara or Cumulus, it doesn't matter. Both are as productive as you can get, I would say, because the only difference is in Payara I would ship the image to ECR to AWS once and then just push the wars, and with Cumulus I will push the jar all the time, but because Docker will recognize the layers and will just layer this as well. This is not a problem. And even Kubernetes doesn't matter anymore, I would say, because what I noticed is what you need is container orchestrator. And or something which starts and stops your Docker files, right? Your images, and because you have to pay for Kubernetes all the time, most of my clients don't use Kubernetes actually because they have to pay for the control plane, and this is crazy because you said whatever. All you said is right, but the next question is no. You actually need 3 Kubernetes clusters. You need something like staging, production, and stuff like that. And the next story is, would you like to share the Kubernetes between projects or not? Should every project have an own Kubernetes cluster, or we have one larger cluster? And then if you have a larger Kubernetes cluster, you have to think, how big is it? And you have upfront, by the EC2 machines. So you have to know roughly how big it is, and you have to patch them and so forth. And this can go, you have to do it. And the next thing is Kubernetes is simple if you are in public cloud. So if your service is publicly available. If it runs in a private subnet, it gets more complex. So you need the nuts and all the stuff, and you need some time. So you need someone who cares about that. What I wanted to say is, for instance, what Amazon has is called ECS or Fargate, and Azure has ACI, Azure Container Instances, and Google has Google Container Instances. I think I forgot the name, and it works like Kubernetes. It's even simpler. You don't need a YAML, but there is health check. There is the scaling. Everything is the same. ACI is a little bit from Azure less capable than the Fargate from ECS, and but still, it is even simpler than Kubernetes and cheaper, way cheaper. But because you don't have to pay for the control plane, but still, the configuration, subnets, how many projects are in a subnet, availability zones, HA, you have to have everything in 2 availability zones. So what it means is you have always to configure the ALB, whatever you're doing, the ALB have to be able to talk. If you have SSL, right, everything goes a little bit more complex. And what I wanted to say is that the complexity of that is way more than the POMs, Cumulus, or whatever. So what makes the complexity in the clouds is no more the POM, Java, or application servers. This was way simpler. The entire thing can be very complex and tedious. Because we are responsible for more than before. Before, everything was in a data center, was set up, and now the cloud is empty, so you can do whatever you like, but you have to do something. And whatever you do has also a business impact because it can be cost more or less. So I have the problem, clients ask me what to do, and I have to say something. Okay, if you go to the public cloud, use Kubernetes, it costs so that much, or use this is a little bit less expensive, but these are the trade-offs. But what people expecting from the cloud is like a way simpler deployment where you can say, okay, here's the applications, run it, and it's managed by someone else, which is absolutely not true, except for very simple cases where you're running Minecraft server somewhere. This is okay, right? But if you have a more complex application, it is interesting.
Well, yeah, this part of the infrastructure as a service layer, or how should I call it, this can get quite complex. But actually, how we do it, if we are using a public Kubernetes in the public cloud, then we almost always use one Kubernetes cluster for all the applications that the company has. Okay. And this setup overhead is then done once. So you have to configure all the networks and everything else. On the other hand, what we also do, we always set up CI/CD, so we automate all the deployment procedures and everything else. But going back to your questions, how many environments you need if you have a Kubernetes? What is really an interesting part, and which motivates me a lot is once you go to the Kubernetes. And once you implement all the fault tolerance patterns and make CI/CD work, and then have all the monitoring tools in place and everything else, then you actually can start to go with one single environment. What I'm trying to say is, you don't need to have three or two or three separate environments, such as test and user acceptance testing and production anymore, but you can go with your updates live into the production environment. And we are currently testing this in a few real world large scale projects. So basically, if you have, what I'm trying to say is, there are several aspects. One of them is how you can deploy new versions of your software directly into the production. And if you are using the microservice architecture, of course, this means that an application will have more than one microservice, so the deployment will have to deploy several microservices. Yeah. And now challenge one here. So the first challenge here is how to set up the system in such a way that each team can deploy its own microservice without waiting and syncing with the other teams.
Yeah.
Yeah. And this is a challenge.
Yeah.
Already this is a challenge. Yeah. However, now, it takes quite some time, particularly if you want to implement this in an enterprise environment, in a larger company or something like that. But so far, we have been successful in quite a few cases, and this is really, well, sometimes I even say, once until you are not able to deploy each microservice of your application and several applications which you are using separately, so without waiting, without syncing, without doing all the dependencies manually, you are not using the true microservice architecture.
Yeah, I'm with you. What you refer to in Kubernetes, what we also did several similar architecture for a bank. What you could do is you could use the namespaces for staging, right? So you can have a project which is visible for dev. It's a dev project, and then you have the same Kubernetes cluster with separated namespaces. I think is the proper name is -n, but the production was a separate hardware cluster. And always, because of compliance reasons, whatever, there was no question about that. This was what we had to do. And what we also had is different Docker registries. So we have one Docker registry for or image registry for the dev and int, and then one from prod. So, and the prod pulled, the Docker registry, and the CI/CD was available, full-blown CI/CD in int and dev, and there was just the deployment CI/CD in prod, which was automated with user approval and so forth. So this I'm with you. So I think we have absolutely the same opinion, and I would say a larger project for me would be 5 such microservices, because we have 5 teams.
Okay.
Yeah, 5 microservices.
Yeah.
And in case of Cumulus, so I have to admit, last time, so in a recent project, I use a lot of Helidon and Quarkus, and this is the same like Cumulus. There's almost no difference. I mean, from the architectural perspective,
it's very similar.
Very similar.
Yeah.
And so I mean, from the Java perspective, it's already you cannot streamline it a lot because it deploys locally in a second, and it doesn't matter actually, right? So and then we push the thing to the cloud. And so what it means is, but still, the one such a microservice per team is, from architectural perspective, a monolith. If we would go to conference 10 years ago, open this microservice and show the code, the architect would say, okay, this is a monolith. There are no OSGI modules, no interfaces, nothing. It's just, it's just Java classes, which is a good thing. So for me, it is a good thing. What I wanted to say is, all the attempts, with all the modularization abstractions, they only increase the complexity, and it was not a lot of benefit of that. So I never
this is where I agree with you. Certainly, particularly if those microservices are, let's say, not so complex. If you have so average complexity microservices, you can go without internal modularization. I definitely agree with you.
But naming is very important.
Even more, we are also seeing, not in Java but overall, is that the object orientation concepts are fading away a little bit. at least in my opinion.
Absolutely.
I started with procedural programming and then working with object-oriented concepts, and I'm still a huge believer of object-oriented concepts, but still for smaller and simpler problems, let's say for simpler microservices, you can go without object-oriented concepts.
Yeah.
And some popular languages don't implement the object-oriented concepts strictly anymore. Yeah. But what I wanted to come back to this discussion about these environments and deployment and so on. Well, if you would like to have an environment where you can deploy microservices, so once they are ready, deploy a new version and so on. What we learned is that without Kubernetes, without Istio, and without some other tools such as Flagger, it simply doesn't work. For example, if you have, I don't know, you have 5 microservices, for example, one of them is pricing microservice, and the team who develops the pricing microservice makes a new version. Now, this can be a minor or a major version. And now, if this team deploys the new version into the environment, the way we do it is that both versions are there simultaneously. So we don't remove the old version, we simply add the new version to the environment.
Yeah.
And then you have those mechanisms how you actually reroute the clients to the new version. And you open the pipe, so in percentage, you say 5% of the calls go to the new versions, the 95% go to the old version, and so on. And then you monitor how it works, whether it works or whether the fault tolerance patterns kick in. And if the fault tolerance patterns kick in, you simply reroute all the traffic to the older versions, and then you have a problem with the new version. Yeah.
Actually, today night, I optimized CI/CD, and this what you described here is already available on AWS. For instance, it's called ECS Blue-Green Deployment. It's just there is no external tool necessary, and what it does is this is the CI/CD pipeline which externally controls the load balancers, and if the health checks doesn't kick in, it just rollbacks the entire thing to the last version. So this and this is without Kubernetes, but is a part of the cloud. It works perfectly. So what I wanted to say, many of the cloud vendors or some of the cloud vendors just try to replicate what Kubernetes does. And this is now part of the platform. And
I know.
And you said without Kubernetes, without Kubernetes you are right, because in OpenShift it also works perfectly. For instance, because
Adam, I agree. Yeah, but what I wanted to say is that if you go with vendor-specific clouds, you have different solutions there. Yeah. But if you want to have a universal solution, which works actually everywhere, you have to go with Kubernetes, you have to go with service mesh such as Istio, and you have to use some additional tools like Flagger and then feature flags and so on. And what I wanted to say is actually that what we are currently focusing is to we are using this in production already. This is not something new stuff for us. We are using this in several real-world projects. We have helped companies to set up such environments. We have helped to build teams which use this in day-to-day development, and it really works very nice. First of all, it is vendor independent. So whatever you have on-premise installation, you have cloud, whatever you have, it is programming language independent. So it works with Java and all other programming languages, no problem. Yeah. And what we are focusing right now, this is what I wanted to point out, is to add this support to make it as simple as possible for each developer to our Cumulus EE framework. Mm-hmm. And this is probably an area where, I'm sure other frameworks also work on that, even have some solutions on that. But this is something which I believe is really important, and this is where we focus our energy currently. And it's also something which really motivates me, because once you set up everything right, so this is what I was describing, is just the deployment of a new version into the environment. But then you have to have in place all the other mechanisms which allow you to monitor all the different microservices versions, have a change management on the versions. You have to know how you will deprecate and remove the old versions, how you will add new versions. You really have to have control over everything. Yeah. And it's quite complex. But this is, well, once you get it right, then you simply don't need 3 different environments anymore. You can then move more and more into a situation where you can live with one environment only.
Yeah, because
And then,
because you created this with your framework or whatever you call it, because you created an overlay over Kubernetes, so this is why it works, right? Because this is the trick.
Right.
But if
Right.
and two things. So I think we are absolutely on the same page with microservices. Now Lambdas or AWS functions, or let's call it functions. So what I think is that functions are perfect, but not for modularization. This is more like a listener or a hook. You know, there are events in the clouds, and the functions are a great way to react, to subscribe to the changes. And such a function could even invoke our microservice or monolith or whatever. So this is the functions. And so I see on your reaction, so you are with you have the same opinion or similar opinion, right? Because what I also saw is a project tried to break up a monolith in, I would say, I don't know, 200, 300 or 400 functions, and this was a mess. This was like in Java we would have one method run with object input and object output, and no one knew what's going on. It was hard to debug because it was a mess. You could potentially replace a method, but no one dared to replace the method because no one knew what happens, right? So there was no framework in place. But what I played with, and this is a great idea. I already mentioned application servers, and I think you are doing something similar. So I would like to explain this first. Application servers, there was the shared deployment, but 10 years ago or 15 years ago, Sun came with something called Sun Grid. So you could zip a file or zip something which was proprietary. I never got it why they did it proprietary, copy it somewhere, and it just ran. And I always ask myself why such a war is not such a thing. So what I wanted to have is serverless application servers, right? and what Payara did, Payara Cloud, they reused the cloud, the cluster mechanism they had, and they became a Kubernetes operator. So they are able, it looks to you like Payara, you put the war, and they are actually creating, the pods for you, and they use, a Kubernetes as a low-level framework. And this is great idea because this is exactly the opposite, to the Quarkus and Helidon, because they try, to ship one small module, and now it's your take, to do something with it. And the Payara and the cloud approach is just give me the war, and we care about the infrastructure. And they have already some rollback functionality. And then I think this is great idea. And what is fascinating, we have two opposite approaches now. Something like Kubernetes orchestrator, where, everything gets deployed automatically. And on the other side, a very small Java cloud native runtimes where they start and stop, if you like. And both are absolutely microprofile compatible. So you can even have, the same programming model and ship one small thing, or just say, okay, I would like to ship today just a war in a server, and Payara will care about that. So I suspect you are experimenting with Cumulus with something similar, right?
Well, this what Payara introduced is a really interesting idea. Yeah. It certainly makes sense. I believe it certainly makes sense for specific application. For example, particularly if you already have a Java or Java EE application, and then you would like to, I don't know, to move it to Kubernetes in a fast way. I'm not sure whether I would use it if I would develop a new application from scratch, but nevertheless, yeah. Regarding the functions, well,
but Matthias, why not? If this is a microprofile, I don't care. If this is Quarkus, I will put it to the war. It's just, if I have both, I could just ship an application to put it to Payara cluster, and if I don't like it anymore, I can still start it as a standalone application, right? So it's not like a big difference.
Yeah, that's right.
Because we have microprofile and Java EE, both the API is identical. It would be just, whether it is a jar or a war. So the difference is a minor.
The difference in the packing doesn't make much. This is not the problem. It's just that. Let me say it that way. How you would internally structure the application into different microservices if this is necessary. It really depends how large the application is. It is really, I believe, a case by case scenario how to decide. But this is certainly something to watch and see whether this will take off, because the idea is really nice. As you said, it's just the opposite of how everybody else is approaching this problem. And regarding the functions that you mentioned, well, what I believe is that functions are sometimes bringing two things. One is that you get this no runtime environment, or free, don't have to take care of the runtime environment at all. Microservices already did a step into that direction, but functions try to do it even more and free the developer for all this mess with the runtime and everything else. But I think the standardization is missing. Functions are now really limited to a certain framework or to a certain vendor that you have to choose upfront, and this is not good. We need something like micro profile for Java microservices. We need something like function profile or something like that for Java, which would standardize how functions are developed, and then they can be deployed on different frameworks or runtime environments or so on. The other thing is that how functions communicate. Well, whether you have this method invocation semantic, or you have this event or message or event-driven semantic, where a function reacts on an event which happens somewhere. And these are two really different things, because you can also microservices, you can interconnect them through events, for example, using a Kafka topic or something like that. And this brings a new dimension into how you develop. Then you go more to the reactive side of developing and so on. You are certainly familiar with that,
If you have Kafka, something like a function is a perfect, or kinesis or something like this is just functions, just shine. But if you're thinking, in microservice terms, or let's say, as a Java developer, what is a function? It's command pattern, right?
It is,
it is command pattern. And now the question is, can you just build easily and cheaply a complex system with just command patterns? And I saw such system in Java, so you can build that, but it is hard to understand what's going on. Because actually, and poisoned message and all the stuff we already had in JMS is a huge problem. And there will be, what we need, a schema. If you get the schema, now the next discussion is, okay, if we have a schema, we need the versions, or we are schema-less, so we don't need the versions. So everything will start again. So what I suspect, we get something like SOAP first, or I'm not even sure, like JSON first, and then we end up having, XML schema then, and then everyone will notice that XML schema is also not a solution. Because if the compiler doesn't work and we cannot consume, then we had the discussion already, right? So type safe versus not type safe, tolerant reader versus a tolerant reader pattern versus XML schema. But I think both are working great. But functions for more flow or reactive, and microservices are a great way to create fast and productive, just straightforward logic. And I would say for something like a database browser like CRUD applications, which is a vast majority of all enterprises are building this, a microservice just fine. But then you get integrations. I would like, someone sends me a message, SNS service from Amazon. I would like to react to it. So Lambda is just perfect. So ship a Lambda, it reacts for it and does something and converts what you understand and you calls you back. And this mix is not well understood right now, because what I see in projects, they say, okay, monoliths are bad without saying why. So my observation is, if someone says, we have to modularize, and I ask why, and there is no answer, it's already a bad sign. So, it's not like you have to modularize because we have fun with it, rather than we have a business problem, and modularization help us to solve the problem.
Yeah, definitely. It's the same as method invocation or event-driven semantics,
Yeah.
What I believe is that an architect the architect who designs the system should decide when to use which. We have, for example, several projects where we use this CDC integration, and here, you need Kafka and events, and they really make sense. And we have also tried this Kafka schema mechanisms, and they work quite interestingly, but somehow I cannot help myself to think that the history is repeating,
Yeah.
as you said, with XML schemas and SOAP and everything else. But still, there are some benefits we didn't have those days 10 or 15 years ago. Yeah.
And also interesting, right? If you play with Kafka, then the next question is, okay, we need schema registry. How to get the schema registry? Oh, this is from Confluent. Where is the source code? Can we download? No, but we can build. I built it actually from source code. It worked well, but you have to download 3 projects, and combine them together, and then you get which is working. You get the Confluent schema registry, but I don't think you can just go with that to your client to say, hey, I built my own server, just run it. So this won't fly. And but how it works is really great with the Avro, right? So it just points to the ID, and on the other one it pulls the ID. So this works great. But for me, the schema registry in Kafka is very similar to table schema. Actually, the same. Because you even mentioned CDC, Debezium, for instance, CDC, you get for every table as a topic with the same structure. So for me, this is exactly the same as the schema then in this particular case as the table schema. And we had the discussion already, right? NoSQL database. Who needs schema? So 10 years ago, there was a huge movement. We don't need schema because it's hard to maintain. And now we get schema in Kafka, right?
Yeah, although this outbox pattern implemented by Debezium, we actually always do also a converter in between because it is too technical. If you just convert the tables into Kafka topics, I think you are missing the point of business events.
Yeah.
What I'm trying to architect in every solution is to have the business events which represent some not simple technical events that go directly through the outbox pattern out of the database table. But this is another topic which we could discuss.
Next time, if you like, in a half a year, let's have a topic about Kafka and events. This would be a great topic. This would be perfect. The same discussion like with and the last thing about the outbox, I do the same because the Kafka topics or the Debezium topics are way too big. You get the old metadata with it's command again, right? C for create, U for update. So I parse it and create, like a converter which reads that and creates then business events. Very good. So, do you have any product to mention? Because you said you solve, the Kubernetes staging problem. Can we point you to a URI or something you have? Or if your clients are interested in your services, do you have something?
Well, this is what I mentioned. This is within the Cumulus EE framework, which is our open source Java microservice framework. Actually, we are extending it with other programming languages as well. We have now Node.js and Golang support as well. Yeah.
Okay,
and we have also some very interesting extensions which go far beyond the microprofile. Yeah. Mm-hmm. But on top of that, we have some other building blocks of the Cumulus platform, which is actually what is our commercial product. Yeah.
Very good. Yeah. So I missed the topic today, but it was a great conversation. So the suggestion is, I will invite you back in 2 months or whatever you have after my deadline, maybe yours as well. And we will have one topic exclusively about Cumulus EE added value and this. The commercial features. I'm really interested in it, to have a discussion how you solve that or what's the idea if you like. And the next session could be about events if you like, or we can combine both.
That would be great. Particularly this part, how you deploy on Kubernetes and so on. These are, I think, some really interesting and innovative things.
Very good. So I'm really looking forward. So thank you.
Adam, thank you very much.
Where people can find you on you are hidden, right? There is no social reference, just Cumulus.
Well, no, I have a GitHub account. You can find me on LinkedIn.
Okay.
Yeah.
So I will put your URIs to the show notes.
Right.
Thank you.
I can send you the links. Thank you very much. Thank you for your time.